Winter in New York can bring many hazards, but few are as intense and localized as lake effect snow. Communities near the Great Lakes can experience rapid snowfall, whiteout conditions, and dangerous travel. This presentation will explain what lake effect snow is, why it impacts New York so severely, and how residents can prepare to stay safe. In this presentation, we will cover the meteorology of lake effect snow, the seasonality of lake effect snow, examples from past lake effect snow events, National Weather Service products issued for lake effect snow, and safety and preparedness tips before, during, and after lake effect snow.
Let's take a few minutes to discuss the science behind lake effect snow. Lake effect snow forms when cold air flows over a relatively warm lake. Now by midwinter, the lake temperature on the Great Lakes is typically in the 30s, but if the air above the lake is in the 20s, teens, or even colder, there's still a significant temperature difference between the warm lakes and the cold air above them. That warm lake water will release some moisture into the air, but more importantly, the warm lake will help to warm the lowest few thousand feet of the atmosphere. That warm air is less dense than the surrounding cold air, so that more unstable air over the lake begins to rise in a column and form a band of lake effect clouds that can deposit heavy snow downwind of the lake. Sometimes lake effect snow bands become quite intense and drop very heavy snow in narrow bands downwind of Lake Erie and Lake Ontario. Now, sometimes our local lakes of Erie and Ontario get some help from the upstream lakes. We can have upstream connections to Lake Huron and even Lake Superior and Lake Michigan. Those upstream connections help to intensify the snow and also help to drive it further inland across New York State. Some additional factors we look at when forecasting lake effect snow: fetch, or how much open water the wind will pass across. We need at least 40 miles to produce lake effect snow, and the more fetch, the better. We need a large temperature difference between the warm lake and cold air, 5 to 10,000 feet off the ground. The amount of background moisture is critically important. The lake can't do everything by itself, so we need a moist background environment already. If the air is too dry, we won't see heavy lake effect snow. Some help from a large-scale weather system that will intensify the lake effect snow. And these snow bands form parallel to the winds a few thousand feet off the surface, so forecasting the wind direction is critical. If we look at the observed sounding from Buffalo on the right side of the screen, a few other things we look for heavy lake effect snow, we like to see a uniform flow direction or wind direction in the lowest 10,000 feet of the atmosphere. That uniform flow will ensure that bands of heavy lake effect snow are able to develop. We also look for a temperature range between minus 10 Celsius and minus 20 Celsius within the cloud layer. That temperature range is favorable to produce large, fluffy snowflakes that are called dendrites, and those large, fluffy snowflakes can really accumulate rapidly on the ground. Lake effect snow comes in several different types. The most intense type is a single band of lake effect snow. This forms when the wind direction is parallel to the long axis of narrow Lake Erie and Lake Ontario. And these are the bands that can drop the very intense snowfall rates and incredible amounts of snow if that single band of snow stays over one location for an extended period of time. Multiple bands of snow form when the wind direction is coming across the narrow axis of Lake Erie and Lake Ontario. And multiple bands can also form when there's more shear in the atmosphere that prevents a single band from forming. These multiple bands tend to be much weaker than single band snow, but they can spread out over a much larger area and drop light to moderate accumulations across most of the region. More rare, but sometimes do occur on the eastern Great Lakes, are mesovortices. These are small areas of low pressure that develop within a band of lake effect snow and can cause the lake effect snow band to become almost circular in nature, like we see on the right side of the screen. These mesovortices can drop locally heavy snow close to the lakeshore as that circulation moves on shore, and can also lead to unexpected band locations and movement as the mesovortice comes on shore. Lake effect snow bands form parallel to the wind direction. So differing wind directions bring heavy snow to different locations in western and central New York. How does Buffalo receive heavy lake effect snow? Sitting at the northeast end of Lake Erie, the heaviest lake effect snow events in Buffalo occur with a southwest wind blowing up the length of Lake Erie. That's a very long fetch over 250 miles down the length of Lake Erie that can drop intense single bands of lake effect snow that drop very significant amounts of snow in the Buffalo metro area. Buffalo can also see lake effect snow with a northwest or north wind off Lake Ontario, but the fetch across Lake Ontario with a north wind is much shorter, so that tends to be much lighter, more limited lake effect snow. With a northwest wind, Buffalo can see minor snowfall from Lake Huron and Georgian Bay. Those are big lakes, but they're a long ways away from Buffalo, so that lake effect snow tends to be light by the time it makes it all the way to western New York. Over in Rochester and Syracuse, downwind of Lake Ontario, both of those cities see their heaviest lake effect snow with a northwest wind off of Lake Ontario. That northwest wind will often have an upstream connection to Lake Huron or Georgian Bay, which helps to intensify the lake effect snow going into Rochester or Syracuse or points between. Lake effect snow can also occur in both of those cities with a north wind off of Lake Ontario. But again, that north wind is a shorter fetch across the lake, and that lake effect snow tends to be lighter in nature. Across the western southern tier, south of Buffalo, the favored wind direction for heavy lake effect snow is out of the west, blowing down a significant length of Lake Erie. And sometimes we see a northwest wind drop heavy snow as well in southwest New York, with an upstream connection to Lake Huron that helps to intensify the Lake Erie lake effect snow. East of Lake Ontario, for Watertown and the Tug Hill Plateau region, the heaviest snow occurs with a west or west-southwest wind blowing down the length of Lake Ontario. And again, we often see upstream connections to Lake Huron, Georgian Bay, and even Lake Superior, helping to intensify the Lake Ontario lake effect snow. Lake effect snow bands, especially single bands, produce incredible snowfall rates. We've seen measured hourly snowfall rates of 6 to 7 inches per hour in the most intense events off of both Lake Erie and Lake Ontario. These very intense, very narrow bands of snow produce a unique situation for residents of western and central New York, and also those trying to travel across the area. These intense snowfall rates result in very deep snow cover on roads and near zero visibility and make travel almost impossible in the most intense portion of these bands.
Let's look at the seasonality of lake effect snow. To first understand why lake effect snow forms when it does, we need to look at the variation of lake temperatures throughout the year compared to air temperatures. The warmest lake water temperatures typically lag the warmest air temperatures of the year by about 2 months. Lake temperatures typically peak in the summer and continue to remain warmer than the air through the fall, supporting rising motions given favorable meteorological conditions. Early in the fall, air temperatures will be too warm for snow to form, leading to lake effect rain events. However, late in the fall, Arctic intrusions of deeper, colder air will begin the lake effect snow season, continuing through much of the winter. Then by springtime, air temperatures become warmer than the lake and inhibit rising motions over the lake through the summer. Based on past events across New York State, the chances for heavy lake effect snow increase by mid-November and slowly diminishes through the late winter in mid-February and early March. The end of the lake effect season for western New York is highly variable and a lot of times depends on the ice coverage on Lake Erie. Lake Ontario does not experience nearly as much lake ice in the winter, allowing the potential for lake effect snow to continue longer for portions of central New York. Additionally, if we look closer to the lakes, these areas are more susceptible to harsh winter weather impacts from lake effect snow, including deep, snow-packed roads, near zero visibility, and possible structure collapses due to heavy snow load. If meteorological conditions are right, though, lake effect snow can extend as far inland as the Hudson Valley. However, heavy lake effect snow is much less likely in these locations further away from the Great Lakes.
Now that we have learned a little about when lake effect occurs, let's look at some past events. The first event takes us back to the 2022-23 winter season from the 16th to the 21st of November. which was an epic lake effect snowfall lasting approximately 60 hours. Snowfall accumulations exceeded 6 feet off Lake Erie and over 4 feet off Lake Ontario, with the greatest accumulations remaining localized to a 10 to 15 mile wide area. What was even more impressive was snowfall rates reaching at times 6 inches per hour, which closed interstates and also prompted states of emergency declarations. Off Lake Erie, lake snows quickly intensified as temperatures aloft cooled, and a band of moderate to heavy lake effect snow developed, with thundersnow reported within 10 to 15 miles of the lake, which is typically of strong early season lake effect snow events. A persistent west-southwest flow positioned a stationary band of heavy lake effect snow over central and southern Erie County, with immediate southern suburbs of Buffalo targeted with the heaviest snowfall, as rates reached 4 to 6 inches per hour. This led to the closure of the New York State Thruway south of Buffalo, and even led to the decision to relocate Sunday's NFL game in Orchard Park. Overall, 81.2 inches was recorded in Hamburg, New York. Off Lake Ontario, a band of heavy snow initially developed over Oswego County and then pushed north to Watertown with the changing wind direction over the lake. While the band was generating snowfall rates over an inch per hour, its transitory nature helped to limit snowfall accumulations before moving into the Watertown area, with snowfall rates occasionally reaching 3 inches per hour. While not as impressive as Lake Erie snow due to the band moving around, 49 inches of snow was still recorded west of Carthage, New York. To sum it all up, what an epic long-duration event off both lakes, with an average snowfall rate of 1 to 3 inches per hour, and as high as 6 inches per hour, which resulted in a high-impact event. For our next event, let's take a look at February 16th through the 18th of 2025. This event was the third consecutive event within a short week-long period of active lake effect snow off Lake Ontario, leading to structural and transportation impacts for multiple days. Widespread snowfall across north central New York eventually transitioned to lake effect snow. The band remained consistent over Oswego County, with steady northwest winds resulting in multi-day snowfall totals in excess of 3 feet for portions of Oswego County. Considerably lower snowfall totals were observed off Lake Erie, with the presence of lake ice along with suboptimal over-lake flow from the northwest, limiting the intensity of the snowfall. Hazardous travel conditions were reported off Lake Ontario along I-81 in Oswego County, leading to numerous road closures extending multiple days. Additionally, the heavy, persistent snow for multiple days resulted in upwards of 24 building collapses across portions of Oswego County, including Williamstown, New York. To sum it all up, off Lake Ontario, 46.3 inches was recorded southwest of Mexico and 38.4 inches north of Onondaga. Last but not least, the historic blizzard that crippled the Buffalo and Watertown metro area during the Christmas holiday weekend back in 2022. The combination of high winds in excess of 70 miles per hour and heavy lake effect snow brought about blizzard conditions beginning Friday, December 23rd, and lasting through Saturday night, December 24th. While blizzard conditions ended, heavy lake effect snow continued Sunday, December 25th, and lasted through Tuesday, December 27th. An exceptionally strong cold front plowed through western north central New York with a rapid drop in temperatures, quickly transitioning rain over to snow. Heavy lake effect snow would rapidly fire up as temperatures aloft tumbled over the relatively warm lake temperatures of Lake Erie and Ontario. A combination of lake-induced snowfall and wind speeds of 55 to 65 miles per hour led to instantaneous blizzard conditions across the Niagara frontier and Buffalo North towns, and also across Jefferson County northeast of Lake Ontario. The strength of these winds led to widespread power outages northeast of Lake Erie and Lake Ontario, including the cities of Buffalo and Watertown. Watertown reported 24.5 consecutive hours of blizzard conditions, while Buffalo observed 37 consecutive hours, halting transportation with the closure of the New York State Thruway from Rochester to the Pennsylvania state line. Airports were also closed to include Buffalo and Watertown, and travel bans lasted 2 days across Niagara and Erie County. When all was said and done, 51.9 inches of snow fell at the Buffalo airport. And off of Lake Ontario, 50.8 inches was recorded. For the details of this truly historic event, or if you'd like to learn more about past lake effect events in western and north central New York, please visit our Lake Effect Archive, which covered warning criteria lake effect events from 1994 to March of 2025 by using the QR code provided in this presentation.
Now let's cover the products issued for lake effect snow by the National Weather Service. Generically, the National Weather Service will issue watches when lake effect snow is possible a couple days in advance for the public to become aware and prepare for hazardous weather conditions. When harsh winter conditions from lake effect snowfall become more likely and expected, the National Weather Service will issue warnings so that you can take the proper actions. Now looking more closely at the specific products issued, winter storm watches will be issued several days in advance and then upgraded to either a winter storm warning, lake effect snow warning, or a blizzard warning based on the expected impacts from a storm. Typically, most lake effect events will be covered by a lake effect snow warning when 7 inches of snow is expected in 12 hours or 9 inches of snow is expected in 24 hours. However, winter storm warnings can be issued when pre-existing widespread snowfall is expected to transition into lake effect snowfall. And blizzard warnings can be issued at times when strong winds will lead to blowing snow, reducing visibility to cause whiteout conditions for over 3 consecutive hours. Additionally, winter weather advisories can be issued when lighter amounts or impacts are expected, but caution should still be taken by the public. Here is an example of these warnings shown on a map. They're zone-based products that typically align with county boundaries, and they can be in effect for multiple days in a row. These warnings and advisories may change, so be sure to have a way to receive the latest updates. The text for these warnings provides details on the expected or possible weather hazards, locations impacted, as well as timing. With the localized nature of lake effect snow, there may be times when heavy snowfall may only be impacting a portion of these locations listed in the warning. Additionally, this text provides impacts expected and recommended actions for you and the public. These products are updated multiple times a day during impactful weather conditions to provide the latest information on timing, locations, and expected impacts going forward through the lake effect snow event.
Lake effect snow isn't just winter weather. It's a hazard that can shut down roads, isolate communities, and turn routine trips into emergencies. In the next few slides, I will go over safety and preparedness tips for before, during, and after lake effect snow. Preparation is key and can save lives. Before the winter season, assemble a comprehensive emergency kit for both your home and car, including essentials like water, food, first aid, and warm clothing. Since strong winds can often lead to power outages, charge your cell phones and have backup batteries ready. Crucially, verify that smoke and carbon monoxide detectors are working and review generator safety procedures. Finally, make sure all your snow removal tools, shovels, blowers, and ice melt are easily accessible before the storm hits. You never know when you will encounter winter weather or an emergency road closure. That is why it's so important to have an emergency supply kit for your car. Some items include first aid kit, cell phone charger, water, snacks, and a flashlight. During a lake effect snowstorm, stay indoors and avoid non-essential travel. Conserve heat by closing off unneeded rooms and dressing in layers. Check regularly that furnace and dryer vents are not blocked by snowdrifts. Ensure proper ventilation for fireplace, wood stove, or space heaters. Never use a stovetop, oven, or grill to heat a space. If you must travel, make sure you are prepared with an emergency supply kit in your vehicle. Dress in warm clothes and reduce speed and increase your following distance. If you become stranded, stay in your vehicle, tie a bright cloth to your antenna or door as a distress signal. Conserve gas by only running the engine for 10 minutes each hour for heat. Lastly, check your exhaust pipe and make sure it is clear of snow to prevent carbon monoxide poisoning. There can be a lot of cleanup after a lake effect snow event. Safety first. Avoid overexertion and lift with your legs, not your back, when shoveling snow. Ice dams can form on the edges of a roof and block melting snow from draining, which can then cause water to back up. Ice dams can cause shingle and roof damage and damage to walls, ceilings, and attics. Look around your house for frozen or broken pipes. Check on your neighbors, especially the elderly and those with medical conditions. Lastly, it's important to restock supplies when it's safe to do so. Remember, shoveling heavy, wet snow can cause back injuries and heart attacks. Don't push yourself. For the weather forecast for your area and weather safety information, please visit weather.gov. On behalf of the National Weather Service in Buffalo, New York, we hope you enjoyed this presentation. Thank you.